Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from limits, right? So here we have to evaluate this limit, that is limit x tends to 2 minus, and the function is the fractional part of x plus 3x divided by mod of x minus 1 plus greatest integer of x plus 1, right? So here we have to evaluate this limit, and here the special thing about this problem is that here we have three special functions in mathematics, that is the fractional part function, the mod function, which is also known as the absolute value function, and this is the greatest integer function, right? And here we see that we have to find the limit when x tends to 2 minus, so this negative sign indicates that we have to find the left hand limit of this function when x approaches to 2 from the left hand side of x is equal to 2, right? So let us start. So now let us first call this limit as capital L, and we have to find the value of L, right? And here x approaches to 2 from the left hand side of x is equal to 2, right? So here we'll make use of the method of substitution, and let us first put x is equal to 2 minus h, right? Since we are calculating the left hand limit, that is the LHL, so we have to put x is equal to 2 minus h, right? And here when x tends to 2, obviously h tends to 0, and here h is a very important quantity, right? And h is greater than 0, and h is very small, right? And h is greater than 0, and moreover it is a positive quantity, right? So now the value of L, by making this substitution, it becomes limit h tends to 0, and here we have the fractional part of 2 minus h. Here we are replacing each x by 2 minus h, right? So now here we have 3 times 2 minus h, and here we have the mod of 2 minus h minus 1, and here we have greatest integer of 2 minus h plus 1, right? Now let us simplify this limit further. So we have limit h tends to 0, here we have greatest integer of 2 minus h, and here we have 3 to the 6 minus 3h, and in the denominator we have mod of 1 minus h, and here we have 2 plus 1 3, so this is greatest integer of 3 minus h, right? So now in order to simplify this limit further, we have to make use of the standard definitions of the fractional part function, the mod function, and greatest integer function, right? So let us take these definitions one by one. Now let us first take the fractional part function. So here we have to express this quantity, right? That is the fractional part of 2 minus h, right? So now we know the definition of fractional part function as fractional part of x is written as x minus greatest integer of x, right? So this is the standard definition of fractional part function, and moreover we know that the domain of fractional part function is the set of all real numbers, and the range is given by x greater than or equal to 0 but less than 1, right? Or this can also be written as like this, that is this interval, right? And now here if we take x is equal to 2 minus h, then the fractional part of 2 minus h, it becomes 2 minus h. Here we'll take x is equal to 2 minus h minus greatest integer of 2 minus h, right? So now we have to calculate this quantity, that is greatest integer of 2 minus h, right? So let us calculate it separately. See, here we have 2 minus h, and we have already stated that h is a positive quantity, that is h is greater than 0, but at the same time h is a very small quantity, right? So if we take for instance h is equal to 0.001, then 2 minus h is equal to 2 minus 0.001, right? And if we calculate 2 minus 0.001, then we'll get 1.999, right? So now here we have to find the greatest integer of 2 minus h. So greatest integer of 2 minus h implies greatest integer of 1.999, and by definition of greatest integer function, the value of this quantity is simply 1, right? That is the greatest integer less than or equal to 1.999, right? So here we can take 2 minus h minus 1, this value, right? So this is 2 minus 1 is 1, so we have 1 minus h, right? Now let us take the absolute value function. So here we have mod of 1 minus h, and we can write mod of 1 minus h as positive 1 minus h, right? Because see, we have 1 minus h. Now h is very small quantity, but h is greater than 0, so obviously h is less than 1, so 1 minus h is always greater than 0, right? So when 1 minus h is always greater than 0, then mod of 1 minus h is positive 1 minus h due to the definition of absolute value function, right? Because mod of x is equal to positive x whenever x is greater than or equal to 0, right? Okay, now let us take the greatest integer function, and here we have the greatest integer of 3 minus h, right? So again, to find out the value of greatest integer 3 minus h, see, we have 3 minus h. We can take, for example, h is equal to 0.001, and 3 minus h is 3 minus 0.0001, right? And 3 minus 0.001 is equal to 2.999. So therefore the value of greatest integer of 3 minus h is equal to greatest integer of 2.999, and by definition of greatest integer function, the value of greatest integer 2.999 is simply 2, right? Because the greatest integer less than or equal to 2.999 is 2. So the value of greatest integer 3 minus h is equal to 2, right? So now this limit L can be written as limit h tends to 0, and for fractional part of 2 minus h we can write 1 minus h, and here we have plus 6 minus 3h, and for mod of 1 minus h we can write simply 1 minus h, and here we have greatest integer 3 minus h, which is equal to 2, right? So now if we simplify it, we have limit h tends to 0, 6 plus 1 is 7, and minus h minus 3h is minus 4h, and in the denominator we have 2 plus 1 3 minus h, right? So now we can simply substitute h is equal to 0 over here and here. So we have 7 minus 4 times 0, and here we have 3 minus 0, and this is 7 minus 0 over 3, and this is 7 over 3, right? So viewers, the value of this limit is equal to 7 over 3, or in other words, the left hand limit of this function when x approaches to 2 is 7 over 3, right? So this is how we solve this important limit.